Okay, good afternoon, everyone. My name is Dr. M. Nagaraju, Assistant Professor in the Department of Computer Science and Engineering, Artificial Intelligence and Machine Learning, Institute of Aeronautical Engineering, Hyderabad. Today, I am here to represent a most important topic in the artificial intelligence, that is forward and backward reasoning. So, before moving and try to understand what this forward and backward reasoning is, we need to have some prerequisites. Some basic kind of knowledge is required. So that we will try to cover at first, then we will move into the actual concept. So the topics for the today's session is I am going to cover three different topics, which is called as Inference Engine, forward chaining and backward chaining. So first of all, we have to talk about the Inference Engine. So before talking about the Inference Engine, let us try to get some kind of prerequisites. Means if you want to understand this particular topic, you need to know some basic knowledge. You need to have some basic knowledge that I will try to give it. Then we will move to the original concept. So what is the previous knowledge is, during our earlier sessions, we used to discuss about the representation of knowledge. We said that being the humans, we are having the capability to represent the knowledge in the English, in English language. But our intention is not to represent the language in English, but we have to represent it in the mathematical form. We have to represent in the mathematical form. So somebody may ask a question, why we need to convert this English representation knowledge into mathematical form? So being the humans, right, if we are having any kind of knowledge in English, it will be very easy for us to understand and to get some kind of inferences. But here, we are not representing the knowledge for our purpose. We need to feed this knowledge to the AI machine. Means the AI machine should be in a stage to understand the knowledge which we are representing in the English language. But as we know that machines cannot understand English, so what we are doing is we are trying to convert it into the intermediate level of understanding, which we can say that it is a mathematical form. So during our previous sessions, we discussed about the two different types of representations. That is by using formal languages like propositional logic, propositional logic and predicate logic, right? These are the two logics which we can call them as the language of logics, which we are using to convert these English representations into mathematical form. Once we have the knowledge representation in the mathematical form, next our primary duty is we need to convert this into the Prolog code. You need to convert it into Prolog code. Why? Because the Prolog code is nothing but an AI program which we are giving to the AI agent or AI machine, which will be executed and it is going to provide us a result. I am repeating this flow once again. You see, first, being the humans, we are representing the knowledge in the English language. So that English language we are trying to convert into mathematical form by using some propositional logic and some predicate logic. Once this representation is done, our next duty is we need to convert this into the Prolog code. Why? Because this mathematical form of representation cannot make an AI machine to execute something and to give the result. It cannot able to give the result. So what you have to do is, by the observations made in the mathematical form, you have to convert that into the Prolog code. Prolog code in general, we can say that it is a AI program. It is a AI program. So this program will get executed and it is going to give some results to us. So this is a kind of problem solving mechanism we generally follow in every case when we are dealing with different real-time applications using artificial intelligence. So knowledge is most important thing for us here. Knowledge representation is the most important thing. So here means when it comes to the inference engine and forward chaining and backward chaining, we have to talk about a specific thing which is called as expert system. We need to understand what this expert system is. We can say that expert system is a backbone of artificial intelligence. Means if you want to solve any kind of artificial intelligence related problems, definitely you need to know, you need to have, or you need to take the help of some knowledge. You need some knowledge to solve them. So that knowledge where we can get it from the expert systems. We can say that expert systems is a repository where you are going to get knowledge. A huge amount of knowledge is already available in the expert system in terms of some programs So that knowledge you can use it and you can solve your own kind of problems. Means we can say that expert system is some kind of supplier. It is going to supply the knowledge to us. In the expert systems, right, if you consider that one as a one of the architecture, if you consider this expert system as one of the architecture, this architecture is going to have two main important components. In that one, the first component is knowledge base. The first component is knowledge base, and the second component is our today's topic, the first topic, that is inference engine. That is inference engine. So we need to know, in the previous sessions we used to know, we know that what is this knowledge base and how we are going to use this knowledge base to solve our problems. But at present we need to understand what do you mean by this inference engine. Why this inference engine is considered as one of the component of the expert system. So let us take one simple example and we will try to understand. For example, if you are doing any kind of experimentation, generally what happens, the outputs from that experimentations will be some numerical values. So what you will do, you will try to represent that entire results in the form of some table. Okay, means after performing the experimentation, whatever the results you got, that you will try to keep it in the form of some tables. But just having a table and some values, it does not mean anything. It does not mean anything. So when this data, means whatever the data you represented in the tables, that will be useful when you are applying some statistical tools. Means until and unless you apply some statistical tools to the data that present in the tables, you cannot come to a conclusion that what you have actually solved or what you have proven. So after completing the experimentations, after representing your results in the tabular form, your primary duty is you need to talk about this, that is called as here, you need to perform analysis. You need to perform analysis. This analysis we can perform by using some statistical tools. Okay, after performing the analysis, our next duty is we need to interpret. We need to interpret the data. Means on behalf of us, right, being an inference engine, its primary duty is it has to perform the analysis and interpretation of data that is present in the knowledge base. Means in simple words, we can say that the inference engine is going to take the knowledge from the knowledge base and it is going to perform analysis and interpretation of data. So what will be the result for this one? Result for analysis and interpretation means you are going to get some new inferences. You could be in a stage to generate new knowledge. Okay, in simple words, we can say that it is going to provide an answer based on the facts gathered from the knowledge base. Okay, you should not get confused here. You see, sometimes we are going to use the word called as knowledge and sometimes we are going to use the word called as facts. Okay, this knowledge we are talking in the general way. But whenever I say it is facts, that means that I am talking in terms of Prolog code. Prolog means programming in logic. Okay, means here the inference engine is making us to generate new knowledge, or we can say that it is going to provide the answers based upon the facts. Okay, based upon the facts are nothing but we can say that based upon the knowledge we have gathered from the knowledge base. So the output for this one will be the new information. Means we can understand in this way. You see, whenever you are performing some data analysis and interpretation on the values present in the table, then you are going to get some new knowledge. New information is going to be generated. So this activity, entire activity is going to perform by the specific engine which is called as inference engine. It is one of the component of expert systems. So these expert systems are of two types actually. Okay, means here the expert system can be of knowledge based. So we can say that it is a knowledge based expert system. So in this case what happens is that it is the inference engine, it is going to acquire and manipulate the knowledge which has taken from the knowledge base to obtain a solution. The solution can be anything. It depends upon the application you are selected. You select. But only the thing is the approach, how the inference engine is following to give the solution to you. So if it is the knowledge based expert system, then the approach it is following is, first it will acquire the data, or we can say acquire the knowledge from the knowledge base, and it is going to manipulate that data. Whenever you manipulate that data, then definitely it will give some new inferences. Through new inferences, you can come to a conclusion. That conclusion can be a solution to your problem. So here what happened, it became too specific. Means the inference engine is completely depending on the knowledge base. Or we can say that the inference engine is completely dependent on the knowledge which is present in the knowledge base. But every time you cannot follow this kind of approach. There is another kind of approach which is called as rule-based approach. So in the rule-based approach, what is happening, you see, continuously you are trying to apply some rules. Okay, rules. There will be some kind of rules which we are going to represent based upon the facts we are having. So whatever the rules are there, that rules you are going to continuously apply to a specific problem statement repeatedly, continuously or repeatedly. So what is the outcome of this one? It is a new knowledge. So what makes you, if you create new knowledge, then it can help us in order to solve the conflicts. Solving of conflicts is nothing but some giving the solutions to a specific problem. Okay, in the inference engine, try to understand, in the knowledge based expert system, we didn't talk about the new data generation. We never talked about the new data generation, but here when it is a rule based expert system, right, definitely every time you are going to generate some new knowledge. Through this new knowledge, again what you can do is you can create or you can generate inferences through which you can come to a conclusion, and that will again leads to a solution. Means resolving the conflicts is nothing but generating some solution or finding some solution to a specific problem. The problem can be anything. Okay, in this session, we are going to talk about a specific problem called as search technique, that we will try to see now. And rules. Here, it is going to apply the rules repeatedly based upon the rules which have generated by the previous applications. Okay, so it is going to add new knowledge to the knowledge base by representing the facts about the world. Okay, so it is called as rule-based expert system. Knowledge-based expert system is too specific to a particular knowledge base, and it will acquire and it will perform the manipulations. But when it is the rule-based application, it is going to generate the new data. Okay, now come to the point. So, okay, now what I told is, right, we are going to solve a specific problem. We are going to solve a specific problem by using this inference engine. Okay, so what the inference engine is doing here, it is performing some analysis and interpretation of data. Once the inference engine is done, next our primary duty is we need to resolve the problems. We need to resolve the conflicts. So, how many ways? In how many ways you can resolve it means there are two different ways through which you can resolve the conflicts. Just now I mentioned that until and unless you select a specific problem statement, you cannot apply any kind of approaches, any kind of AI technique you can say. So, in that case, what I am doing is I am specifically selecting a problem statement, a problem which is called as a search problem. Okay, so as we said that it is a search problem, two things comes into picture, right? What I have to search first thing, and in between what. Okay, so for a search problem, definitely there will be two states. One is called as initial state. Initial state means the state from where you are starting the search process, and there will be another state which is called as a goal state. Okay, which is called as goal state. Means in the search process or while resolving the search process, your primary duty is you need to identify the initial state and the goal state. And what is our motto? Our motto is we need to identify a specific path between these two. Means performing the search activity here is nothing but identifying a path between the initial state and the goal state. Okay, so what I am telling is there are two different ways. There are two different ways how you can search for a specific path. Okay, one way I am telling that it is a forward path or forward search we can say, or otherwise we can say that it is a backward path or backward search. The question is which one is called as forward and which one is called as backward. If you start your search process from the initial state and moving towards the goal state, then we can say that it is a forward pass or forward search. If you are starting from the goal state and moving towards the initial state, then we can say that it is a backward search. Okay, so there are other differences also. For example, if you see specifically in the forward search, what happens? There is a question: what happens next? Means some situation has happened already, or otherwise we can say that you are in this place. You are in this place. Then what will be the next? Okay, what will be the next? So if you are thinking about this kind of things, then we can say that it is a forward search. Okay, so in the forward search, our concentration will be on this particular question, that is what happens next. So for clear understanding, we can say that it is a process of applying the conditions. It is a process of applying the conditions, means continuously we are going to apply the conditions. When specific condition is met to a specific situation or state, then we can say that we are going to move to the next state. Okay, so decisions is taken based on the availability of data. Decisions will be taken based on the availability of the data. For example, think that you are performing the search activity from your home to an unknown place. There will be some name to this place, but it is unknown to you. Means you have not seen this place earlier. Okay, we can say that it is an unknown place. So your search activity is you need to find out the path between your home and the unknown place. So during your search activity, what you are doing, you are taking the help of the data which is already available to you. Based upon that data, continuously you are trying to move in between this until and unless you reach to this unknown place. Okay, so we can say that this is one kind of forward search process. But it is not the case in the backward. In the backward, this will be the case. Why this happened? Okay, why this happened? So in this case, what we are doing, we are trying to find out the causes or the reasons for this happening. Okay, that means that generally initial state is fetched based upon the decision. Okay, we will take a very simple example and we will try to understand what do you mean by this forward search and backward search. Okay, if you try to observe these two pictures, there are two people involved in this case. This one is a doctor and this one is a patient. Now we need to understand that who is going to apply what kind of search process. Okay, in general what happens, the patient is going to perform the forward search process. He is going to perform some forward search process. Why? Because the situation has happened. The situation has already happened. For example, think that he fell sick. So being a patient, what he do is he will try to identify or he will try to understand how to overcome this one. How to overcome this one. But when it comes to the doctor, it is not the case. What the doctor will do, he will try to identify the causes, what made the patient fell sick. So we can say that he is going back. He is trying to do some kind of investigations to understand what is the reason that made the patient to fell sick. So we can say that the doctor here he is following the backward reasoning, or we can say backward search, and the patient is following some forward search process. Coming to the properties of forward reasoning. See, forward reasoning, forward chaining, forward search process, both are same only. Okay, so the forward reasoning, we are saying that it is a down-up approach. It is a down-up approach. Why? Because we are moving by taking this forward chaining process. Forward chaining means you are moving from the initial state to the goal state. You are moving from the initial state to the goal state. Then we can say that it is a down-up approach. Okay, otherwise we can say that down-top approach also. And this process is completely depends upon the facts and data which is available to you. So by taking the help of the existing data, you are going to move towards the goal state. This process you are going to continue until and unless you reach to the goal point. Okay, let us take one simple example. This is your initial state. This is your initial state and you need to perform the search activity. Nothing but finding out the path between these 2 points in order to reach to the goal state. Okay, so what you have to do, you need to find out a path, or otherwise we can say that we have to continue moving. We have to continue moving towards the goal state. So what makes us to move towards the goal state? The rules. The rules are, otherwise we can say, conditions. The rules are conditions, means whenever you identify some specific rules or some specific conditions, that conditions you need to apply to your initial state. You need to apply to the initial state. When you apply them, what happens is it is going to generate, means the application is going to generate the new configuration. The new configuration is nothing but your new state. So after reaching to the new state, again you have to identify what are the rules that are matching to this particular situation. Particular state. You need to apply. When you apply, what happens? Again, new configuration will come. So that new configuration will makes you to move towards to the next state. Means continuously you keep on applying the rules. Means you need to identify the rules which are applicable to that particular situation, particular state, and you need to apply it. Once it is applied, it is generating the new configuration. That is nothing but your next state. Your next state. So we are going to continue this process until you reach to the goal point. Okay, so we can say that this rule. Okay, this rule is having 2 parts. We can say. Okay, one part is the left side part, and another one we can say that it is a right side. What the left side of the rule will have? Your initial state. Your initial state, or otherwise we can say that it is a current state. If your position is at the starting point, then we can say that it is an initial state. If your position is somewhere here, okay, somewhere here, then we can say that it is a current state. So what you are doing, you are applying the rule or you are applying some condition. When it is the case, what happens? A new configuration is going to come. New configuration. Your new configuration is nothing but your new state. Your new state means the left hand side of the rule you are applying to the specific state, and that is going to give you the new state, a new configuration. So this process we are continuing up to the goal state. Means when you reach to the goal state, you are going to stop this applying of rules. It is commonly utilized where these are applicable, means these are generally used in the production rule systems. Coming to the properties of backward reasoning. Just now we discussed that in the forward reasoning, our search process will continue or will start from at the initial state, and it will continue towards the goal state. It is a forward path, as forward search. But in the backward search, what is happening? Instead of moving from initial state to goal state, we are trying to move from the goal state to the initial state. So in this case, what happens is we are going to split our goal into sub goals. We are going to split into sub goals. Means at this case, means during this approach, okay, during this approach, we can say that we are not following or we are not having a single goal. We are having multiple goals. Means goal will be only one. What is that? We have to reach to the initial state. Why? Because our search process in the backward reasoning, it is starting at the goal state. So you have to identify a path towards the initial state. Okay, so during that, what we are telling is it is a kind of top-down approach. Try to understand these things. What is that? One, if it is, if you are starting from the initial state and moving towards the goal state, then we can say that it is a forward reasoning or forward chaining. If you are starting from the goal state and moving towards the initial state, then we can say that it is a backward reasoning. This is backward and this one is forward. It is a forward. If it is a forward, then we can say that this kind of approach is a down-top approach or down approach, we say. If it is a backward, what happens? We say that it is a top-down. Why it is top-down? Because we are performing the search activity from the goal state. Means we are starting from the goal state, not from the initial state. That is the only difference. In both the cases, our intention is same. What is that? We need to find out the path between the two states. But only the question is from where you are starting. But from where you are starting to identify the path. If you start from the initial state, then we can move towards the goal state. Then we can say that it is a forward reasoning. If you start from the goal state and moving towards the initial state, then we can say that it is a backward reasoning. That's why we call the backward reasoning as a top-down approach. And in the backward reasoning, just now I told that we are going to split. Okay, we are going to split the goal into sub-goals. Okay, means for example, you see, these are two initial states you are having. Two initial states. This is a goal state and this is your initial state. So in between what happens, you are going to have some multiple states. Some multiple states will be there. These multiple states are nothing but some sub-goals. We can say sub-goals. Means initially, right, we are having only one goal. That is, we need to reach to this point. We are not thinking about that. We have to reach to the initial point. That is actually our main goal. But in between what is happening, we are creating our sub-goals. So what we have to do is, we need to identify the same thing. Whatever we have done in the forward reasoning. Here what we have to do, if your position is here, you need to identify the rules which are applicable to this particular position. So you have to apply it. When you apply that, when you apply these rules, a new configuration is going to come. That new configuration is nothing but this one. So what happened? You have reached or you have succeeded reaching one sub-goal. And next again, to this particular point also, you need to identify the rules. Which rules are applicable? These rules we will get it from the knowledge base. Okay, so to this particular point also, you need to identify which rules are applicable. You apply that rules. A new configuration will come. That new configuration is nothing but your new state. You keep on doing these things, right, until you reach to the initial state. That's why we are saying that in backward reasoning, we are going to have sub-goals. Means the main goal itself, we are trying to split it into several goals. That point only I have mentioned here. The goal is broken into sub-goals to prove the facts true. Okay, it is also called as, we can say that this is also called as a goal-driven approach. It is called as a goal-driven approach. Why? Because a list of goals we are going to decide. A list of goals we are going to decide where we are applying the rules continuously. Means selecting and using is nothing but some kind of applying the rules. As we are doing it regularly, so we can say that this kind of approach is also a goal-driven approach. And in backward reasoning, where we are using this backward reasoning means especially when we are dealing with applications related to game theory, inference engines, and some other artificial intelligence applications. Then generally we work with the backward reasoning concepts. So there are two possibilities are there. Means how you can solve them. If it is the reason forward from the initial state, means you are trying to apply the forward reasoning. Okay, if you are applying the forward reasoning, our next duty is, means once you identify the rules and apply it and try to get the new configurations, our next duty is we need to draw a graph. We can say that we need to draw a tree. What tree it is called as? It is called as a search tree. So how to draw this search tree for the forward reasoning and for the backward reasoning, that we need to understand. So if it is a forward reasoning, our first step is we need to build a tree. So from where we are starting? We are starting from the initial configuration. Initial configuration is nothing but our initial state. Okay. So what will be our initial state? Especially remember, this initial state will be always the root of the tree. Means here, initially we are going to identify one particular thing which is called as a root here. This is the root. So during our first process, in the first step, we have identified the initial configuration. Means from where we are starting. Obviously, we know that we start from the initial state. Why? Because it is a forward reasoning. So that initial configuration, I am considering it as a root. So my next duty is I need to generate the nodes in the next level. Generate the nodes in the next level. So how can I do it? I need to first of all find out the rules which are applicable to it. Just now we discussed. Once the rules are identified, just keep on applying it. For example, think that there are 3 rules. You have identified 3 rules which are applicable to this particular situation. So when you apply 3 rules, there is a possibility of getting 3 nodes in the next level. Getting 3 nodes in the next level. Once it get done, again you need to identify the rules and you need to check for these things. You need to check for this level. Initially what you have done, you have identified rules and you try to apply to the root node. Why? Because at that time in the search tree we are having only one node, that is the root node. But what happened when you identified and you applied some rules, you got the second level nodes. So now we are not going to bother about the root. We are going to bother about the nodes which are present in the next level. For this also, you need to identify the rules. Which one is applicable? That rules you have to apply it. That rules you need to apply it so that you can generate some other level of the tree. Some other level of the tree. So this search process we are going to continue until we reach to the goal state. Until we reach the goal state. So this kind of process we can say that it is a forward reasoning. It is called as forward reasoning. So our third step will be generating the next level by considering the nodes. Means first we need to consider root node to generate the next level nodes. Then we need to consider the next level nodes to generate the other level. Okay, this is the approach we follow in the forward reasoning process. But the very important point you need to observe is here, the left hand side matches against the root node. Just now I told that role is having 2 parts. Okay, one part we say that it is a leftmost part and another one is the rightmost part. So if it is a forward reasoning, in the leftmost side what will be there? It will be the initial state. It will be initial state, or otherwise we can say that it is a current state. Okay, in the right hand side what happens? A new configuration will be there. Okay, a new configuration. So what is this new configuration? That new configuration is nothing but your new state. So what is happening? We are applying the leftmost rule here. Means in the rule, the leftmost part we are trying to apply to get the rightmost part in the forward reasoning. So whatever we have discussed so far, that will be entirely reverse in the backward reasoning. That we will try to see now in the previous level and apply it to all the rules. Whose left hand side matches. Okay, come back to the backward reasoning. In the backward reasoning also the same thing you see. We have to build the search tree. We have to build the search tree, but what we are considering here, we are considering the goal node. In the forward reasoning, we considered the initial node. Here we are considering the goal node. Why? Because just now we told that backward reasoning means your search process will start from the goal state, not from the initial state. Okay, so in this case also what you are doing, you are trying to identify the rules which are applicable to generate the next level. But only the thing is, you are going to consider the right hand side Previously, we considered the left hand side. Why? Because it is a forward search or forward reasoning. But in backward reasoning, we are going to consider the rightmost part. Why? Because it is a backward process, no? So we need to consider the rightmost part in order to get the leftmost part. That is the only difference. The same thing. So we have to follow the same thing and we have to generate the search tree for this one. So next step will be, we have to generate the next level by considering the nodes in the previous level and applying it to all the nodes whose right hand side matches. That is important. In the forward reasoning, we are looking at the left side part. But in the backward reasoning, we are looking at the right side part. So there are two different ways how we can solve the problems. Okay. So one way is here. This is the forward reasoning. That is the left hand side. We are going to consider left hand side left hand side of the rule we are going to consider, and whenever it is matching to the current state, then we are going to consider about the right hand side to generate the new state. This is in the forward reasoning. In the backward reasoning, it is reverse. In place of left hand side, we are considering about the right hand side. When the right hand side of the rule is matching to the current state, then we are moving towards the left side. Means the state which is at the left side, that will becomes the new state for us. Why? Because it is a backward search. Let us try to understand one simple example. Right? This first diagram is talking about the forward search or forward reasoning, and the second one, it is talking about the backward reasoning. So what happened in this example? There are two facts given to us and one rule. What is that? He is running. If he is running, he sweats. So what is the goal state? He is sweating. Means you have to start from this initial point and you need to reach to this particular point. What is that? He is sweating. But if you see in the backward reasoning, it will be in the reverse fashion. Means here what happened? A has become the initial state and B has become the goal state. But in the backward reasoning, B will become the initial state. B will become the initial state and A will become the goal state. But we are not going to change the states here. The state labels will be same. That is, from initial state to goal state, if you move, then we say that it is a forward search. From initial state to goal state. Maybe you can say that from A to B. If you are moving from B to A, then we can say that it is a backward search. Means if you talk in terms of this explanation, we cannot say this one as an initial state. Of course, you are performing the search activity from this point, but you should not supposed to change the label. So your label should be GS only, goal state. Towards which point, which state you are moving? Towards the goal state. But here A is not a goal state. Of course, for that reasoning it is goal state, but the label is the initial state itself. So you should not supposed to say it as a GS. You have to call it as a IS itself. Simple, right? From IS to GS, if you move initial state to goal state, then we can say that it is a forward search. If you are moving from goal state to initial state, it is a backward search. So what happened here? You see, in the forward search, he is sweating is our goal state. But when it comes to backward search, our goal state is this one. We are starting from that point. What is that? He is sweating. So what is the rule? Means what made us made he to sweat? He is running. If he is running, definitely he sweats. So ultimately we can say that he is running. Okay. This is a simple example through which you can understand how forward reasoning and backward reasoning can be applied. So we will try to improve or change the complexity of the example. Why? Because you should not supposed to take the AI related problems will not be that much simple to understand. So we have to take the real kind of problem and we need to apply it. So before directly moving to the complexity of the problem, I am trying to reduce the complexity for your understanding. Initially, I have taken the basic example. This is the basic example to understand how this forward reasoning and backward reasoning will work, and then I will improve or I will change the complexity little bit and then I will take the main example to understand how this forward reasoning and backward reasoning can be applied. So this is the example. So this is the knowledge we are having. Okay, we can say that this is the knowledge we have collected from the knowledge base. So from this knowledge, what you have to do is we need to prove some facts, or you need to prove something. What is that? You see, if D barks and D eats bone, then I am saying that D is a dog. This is the knowledge we are having. And if V is cold and V is sweet, then we can say that V is a ice cream. If D is a dog, then D is black. If V is a ice cream, then it is vanilla. So this is the knowledge we are having. So what we have to do is we need to derive the forward chaining process using the given facts. These are the facts, knowledge, or otherwise we can say this is the facts. By using these facts, we need to prove. What we have to prove? We need to prove that Tommy is black. Means if you want to prove Tommy is black, you try to observe this one. If you want to prove Tommy is black, before that you need to prove that Tommy is a dog. Once we could able to declare or solve or prove that Tommy is a dog, then we can say that it is black. Why? Because based upon the knowledge we are having, or based upon the facts that are given to us. Okay. So how it will be using? From the first statement, means from this statement, what is that? If T barks and T eats bone, then I can say that D is a dog. With this statement, I can generate some new inferences, you see. If Tommy barks and Tommy eats bone, then Tommy is a dog. So just what I have done, in place of D, I replaced, or I have used Tommy. Just I replaced the variable D with Tommy. Okay, so if Tommy barks and Tommy eats bone, then I can say that Tommy is a dog. That is through the equation number 1. If you talk about the, fact number 1. If you talk about the fact number 3, then this is the case. If Tommy is a dog, okay, from statement 3, if Tommy is a dog, then obviously Tommy is black. Means in this first case, means after applying the first fact, we have proved that Tommy is a dog. Why? Because this representation is exactly matching with the knowledge provided to us, facts provided to us. So with this first statement, we have proved that Tommy is a dog. That is our first goal. Once it's done, by using this statement, we are saying that Tommy is black. Why? Because in the facts itself, we represented that if D is a dog, then D is black. Okay, so like this we can able to prove that Tommy is black. So this is called as some forward reasoning approach to prove something. So what is the advantage we are having in this forward search? So what is the advantage? You can draw some new inferences from the given facts. Now we try to work on the backward reasoning. The same example, the same facts are given to us. Only the thing is we need to prove. What we have to do? Prove the same thing, that is Tommy is black. So the approach will be different. Why? Because we are not following the forward search here. We are following the backward search. So in this case, how we are going to do it? The solution will be this one. See, whatever we have done in the forward search, the same process again we are going to follow here. But only the thing is how we are starting. Either you are starting your process from the search initial state, or you are starting from the goal state. So here what happened? Directly I am taking the statement 3, fact number 3. I am not talking about fact number 1. Why? Because in forward reasoning we talked about fact number 1 and then we moved to the fact number 3 to prove that Tommy is black. But in this case directly I am taking Tommy is the equation, the fact 3. So from this fact 3, what happened? If Tommy is black, is a dog. If Tommy is a dog, then Tommy is black. So what happened? Without taking the help of the fact number 1, directly by using this fact number 3, we could able to prove that Tommy is black. So the goal is matched with the above axiom. Let us try to see. Already just now I told that in the backward reasoning, there will be no single goal. There will be some multiple goals. There will be some multiple goals. So what you have to do is, with this proving, right, we need to generate new questions from this one. So what is our new next goal? You see, our next goal is we have to prove that Tommy is a dog. Just now we proved that Tommy is black, but we didn't prove that Tommy is a dog. So our duty is here, we need to prove that Tommy is a dog. So how can we do it? Here we are not considering about the fact number 3. We consider about fact number 1. So what is fact number 1? If D barks, in the fact it is mentioned as D. So what I am doing, I am replacing that D with Tommy. So if D barks, means if Tommy barks and Tommy eats bone, then we can say that Tommy is a dog. So what happened? Even we have reached to the goal state. Our first goal is we need to prove that Tommy is black. Our next goal is we need to prove that Tommy is a dog. To prove Tommy is black, we have used the fact number 3. To prove that Tommy is a dog, we used fact number 1. In forward reasoning, what happened? First you used equation fact number 1 and then you used fact number 3. But it came in the reverse fashion. Okay, so let us try to see some other goals. We will try to generate some other goals here. So what is our next goal? We need to prove that Tommy barks and Tommy eats bone. You try to observe the difference. First, we have started with the statement that if D barks and D eats bone, then D is a dog. But in this case, what happened? We are proving it. Means we are proving fact number 1 at the last. Why? Because it is a backward search process. So our primary duty is here we need to prove. This is our new goal. We need to prove that Tommy barks and Tommy eats bone. So how can we do it? By using this one. So what we have done is we have splitted, okay, that particular sentence we have splitted into 2 sentences. What is the 2 sentences? One is Tommy barks and another one is Tommy eats bones. So from equation 1 itself, means from fact number 1 itself, it is proven that Tommy is a dog. Why? Because in that fact number 1, it is mentioned that if Tommy barks and if Tommy eats bone, then Tommy is a dog. Okay, so once we prove that Tommy is a dog, so with the statement number 3, we can prove that Tommy is black. Okay, like this we need to follow the backward search process. Now this is the example number 3. Okay, in the example number 1, we talked about running and sweating. In example number 2, we talked about proving that some Tommy is a dog, some Tommy is black, some Tommy eats bones and it barks, such kind of things. But the actual thing, means the actual application where you can apply this forward reasoning and backward reasoning is identifying or solving these kind of applications itself. So this is a problem statement given to us. So what is the problem statement? As per the law, it is a crime for an American. It is a crime for an American to sell weapons to the hostile nations. So country A is an enemy of America, has some missiles. It is having some missiles. So all those missiles were sold to it by robot. Okay, so who is an American citizen? Who is robot here? Robot is an American citizen. This is a paragraph given to us. Okay, this is a problem statement. From this problem statement, we need to prove. What we have to prove? We need to prove that robot is criminal here. Robot is criminal. Why? Because this paragraph is telling that robot is a person, robot is a citizen of America who sold some weapons to the hostile nation A. Means here A is the enemy of America. This paragraph is telling giving that knowledge. But being the human, for us it is very easy to understand. But for an AI program or for an AI agent, how we need to give it? How we can resolve it? So already we know that at the starting of this session, I told that first our primary duty is we need to find out the English representations. Next we have to go for representations in the form of some mathematics or some mathematical symbols. Mathematical symbols. And our next duty is we need to convert into some Prolog code. So this is a problem statement given to us. Once the problem statement is ready, next our duty is we need to represent the knowledge in the English. So we can say that those one are the facts. Once the facts are ready, then by using some formal languages like propositional logic and predicate logic, we need to convert these facts into the logical representation in some symbolic representations. But here we are not considering the propositional logic. Why? Because we are having some limitations in propositional logic. So we are taking the help of predicate logic. Predicate logic, or otherwise we can say that first order predicate logic. Okay. So once this is ready, our next duty is we need to convert into the Prolog code. But in this session, we are going to stick on up to this particular point. Converting the English representations into facts, trying to convert these facts into predicate logic form, and next we will try to generate the search tree also. Generate the search tree. So how can we do it? Let us try to see. So the given facts are this one. What is it? It is a crime for an American to sell weapons to the enemy of America. These are the facts which we have generated from the paragraph itself. There is no any new facts. Okay, how many facts you identify, that much easy it will be to apply and to solve something. So what is the first fact? It is telling that it is a crime for an American to sell weapons to the enemy of America. Country A is an enemy of America. Country A has some missiles. All the missiles were sold to A by robot. Missiles are nothing but some weapons. Robot is an American. So this is the knowledge we have identified or we have observed from that particular paragraph. So by taking the help of these facts, you need to prove that robot is a criminal. Robot is a criminal. So how can we do it? Our first step it is we have fulfilled it. Representing our knowledge in the form of facts. Once it's done, next is convert these things into the predicate logic form. So these are the conversions. Okay, so if you want to understand these kind of representations, you have to see one of the lecture given on the first order predicate representations. So you least bother about these symbols. Okay, these symbols are some points. Means there are 6 facts and we are converting these 6 facts into predicate logic. Okay, these are the representations. Okay, so once we get the representations, okay, our next duty is we need to convert this one into the search tree. Means we need to draw a search tree based upon the facts given here. Okay, it will be like this. Okay, so here it is this one you see. We are going back from down to top, we can say. It is down, it is top. For your understanding, you have to start from the low level, the down level. Means this graph, we are talking about the forward reasoning approach. So in the forward reasoning approach, the knowledge what we are having is this one. What is that? Robot. This is the object. So who is the robot here? Robot is an American. Some X. What is this X here? X is a missile. And one more information. What is that? Owns. Who owns A? Okay. A owns. Okay, it will be like this. But the way of understanding will be in this fashion. A owns X. Who is A actually? We know that A is the hostile nation. Means enemy of America. So enemy of America A owns X. So what is X here? X is missile. Another fact is also there for us. What is that? Enemy. Who is the enemy again in this way? A is the enemy of America. A is the enemy of America. So these are the 4 facts we are having initially to move towards the goal state. So from these existing or available facts, we are generating the next level of the tree. Okay. So what is the next level? With this one, means with this statement, if the robot is an American, directly we can say that robot is a criminal. Why? Because in the paragraph itself, it is represented that robot is the person who sold missiles to A. So with that fact, directly we can say that robot is a criminal. Why? Because robot is an American. the other possibilities. Means from this case also you can prove it. How? If X is a missile, you try to represent that X as a weapon. Okay, if X is a weapon, so we can say that we are taking the help of these things. Who is owning that X? It is owning by the, okay, it is owning by A. So how A owns the missiles? Because robot sells it. So what happened here? Robot sells missiles to A. This the sentence representation we are doing in this fashion. Okay, robot sells missiles to the hostile nation A. Okay, means with these two knowledges, with these two facts also you can prove that robot is a criminal. Or otherwise you can take the help of these two representations, these two facts. Talking about missile X and talking about the nation. A is having the missiles. So who sold that machines, that missiles? The robot. So who is the robot here? Robot is the American. So obviously what happens? Robot will become the criminal. Okay, the same way from here also. The enemy. Who is the enemy? A is the enemy. Enemy of whom? Enemy of America. So obviously when A is the enemy of America, so we can say that A is the hostile nation. Okay, means this will be our next level of representation. Through these three levels, again you can prove. Means there are three different possibilities you are having. Means by taking the help of the facts, right, all together you can prove that robot is a criminal. Robot is a criminal. So in this case, what happened? In this level, we are proving that robot is a person who sell missiles to A. And we are also able to prove that, right, A is the hostile nation, means the enemy of A. So why we are saying that A is a enemy of A? Okay, why we are saying that this kind of things? Because here the weapons. Okay, who sell these weapons? Robot has sell these weapons. Though with these facts we can say that robot is a criminal. Means directly you can move in this path, or you can take the help of these things, and you can prove it. As you are moving from down to top, we can say that this is a forward reasoning approach, where you are taking the help of the facts available and trying to prove that robot is a criminal. The same strategy we are following in the reverse fashion. Okay, in the reverse fashion for the same one, backward reasoning, remember there will be no change in the facts. Why? Because our problem statement is same. We are not changing the problem statement. Only the thing is how you are approaching. So the facts will remain same. So these facts and the previous case facts both are same only. And representations also will be same. There will be no change in the representations. Means predicate logic representations. But only the thing is the search process you are performing will differ. So what happens here? It will be like this. Means instead of moving from down to top, here you are trying to move from top to bottom. Top to bottom. Okay, means we are starting from this point itself. What is that? We are directly telling that robot is a criminal. So immediately what will be the next question? You have to prove it. How can we prove it? Means by taking the help of the facts. What is that? Robot is an American. We are talking about some weapons Y. Okay, right? X or Y, that is a constant. You can only for a differentiation I have used Y here. So what is the other fact you are having? Robot has sell the weapons. To whom? To A. What is A here? A is the enemy of America. So next, we are talking about the weapon. So what here in the paragraph we don't have this word. In the paragraph we are having a word called as missile. So we need to prove that Y is a missile. Means to an AA agent we are differentiating. We are telling that the weapon is nothing but a missile. So what is the knowledge we are having? One is selling and another one is owns. Means initially in the forward reasoning, we are taking the help of the facts available and we are trying to prove that robot is a criminal. But in this case, in the backward reasoning, what we are doing is we are starting from this point, directly telling that robot is a criminal. So we are going on, we are continuing our search process to collect the evidences. Means what are the evidences that are available to prove that robot is a criminal? So that evidences are nothing but utilizing the facts that are given to us. Okay, so this is a backward reasoning approach. But there are some influencing factors are there. How many influencing factors are there? There are 4 different factors that can influence on the reasoning. The first one is, are there more possible states or goal state? Means what happens if there are multiple goals, multiple starting states and multiple goal states. Okay, why? Because it depends upon the application you are selecting. Means if your specific problem is having some multiple starting points and multiple goal points, then the strategy whatever we have discussed so far will not be applicable. Okay, right? Means whenever if your problem statement is having only one initial state and only one goal state, then we can follow this kind of approach or this kind of strategy. Okay, what is that? So we move from smaller set of sets to the length. Okay, means that there are multiple initial states and there will be some multiple goal states. Sometimes what happens, there will be only one initial state and there will be multiple goal states. Okay, otherwise we can say that there is only one goal state and we are having multiple initial states. Okay, so what is the next factor? In what direction is the branching factor greater? Okay, we talk about this branching factor in the heuristic search techniques. You can think that this branching factor is just a numerical value at present. Okay, we are talking about the numerical value, or otherwise we can say that it is a distance between one state and the other state. Okay, so the first influencing factor is, if your problem is having multiple initial states and multiple goal states, the approach is going to change. And it is also depends upon the branching factor. Why? Because first we are talking about the identification of path from the initial state to the goal state, or from goal state to initial state. Okay, but we are not talking about the shortest path. Why? Because if you think of the shortest path, then it will become the optimized path to it. Okay, so how you can get that optimized path? By considering this branching factor between the nodes. Okay, so what is in this one, you see, we proceed in the direction with the lower branching factor. For example, this is your initial state. This is your current state, we can say. This is your current state. From this current state, there are 2 possibilities. Okay, there are 2 possibilities are there for you to move. So which one to select? Either to select this path or to select this path. So for that one, we are considering the branching factor. Okay, at present you think that this branching factor is some numerical value. So here the branching factor is 5. Here the branching factor is some 7. So what we are telling is, whenever your search process is showing some multiple paths to you, so you try to consider the branching factor which is having lower value. So here when you compare with 7, 5 is the lower value. So you are just ignoring this path and you will continue in this path. Okay, so this will be one of the reason for your influencing factor during your search process. It will definitely influence. And will the program be asked to justify its reasoning process? Okay, we can say that we may or we may not. Okay, so it is selected since it is very close to the way in which the user thinks. The fourth influencing factor. What kind of event is going to trigger a problem solving episode? Okay, so this is also one of the influencing factors. So if it is the arrival of the new factor, okay, if it is the arrival of the new factor, then we are going to follow the forward reasoning. If it is the existing factor, then you have to follow the backward reasoning. Okay, there are 4 influencing factors means 4 factors that can influence your search process. One is, if your search process is having multiple states, multiple initial states or multiple goal states, then it will be a problem. Our next factor influencing is the branching factor. Okay, when you are having multiple paths, you need to consider the branching factor which is having the low value. And the third one is you are going to provide any reasoning to the user. And the fourth one is this one, talking about the factor, whether it is a new factor or the old factor. Okay, if it is a query, means if it is your query, then we can say that which a response is desired. Which a response is desired, then we can say that it is a backward reasoning. Okay, means if you are talking about generation of the new factors, then we can say that it is a forward reasoning. If you are talking about the responses, giving of responses, then we can say that it is a backward reasoning process. Sometimes what happens now, there will be some applications where you need to apply the forward reasoning and backward reasoning in the both cases at the same time. Previously what we have done, we have applied the search process separately, following the forward approach and following the backward approach. Okay, but here what is asking is, we are talking about the bidirectional search process. Bidirectional search process means, if for example this is your initial state and this is your goal state. In bidirectional search process, you are starting your search process from both the sides. Means you start from the initial state, simultaneously at the same time you are going to start from the goal state. So this process will continue. This process will continue somewhere you reach to a particular point. So what happened in this case, you have applied the forward reasoning, means you are following the forward reasoning approach as well as the backward reasoning approach. Then we can say that it is a bidirectional search process, where you can apply the forward reasoning and backward reasoning at the same time. Okay, so this is the diagram which we can say. This diagram talks about the forward reasoning. Forward reasoning is completely depends upon the goal state. Means we think about the goal state. We didn't think about the other factors. But in the backward reasoning, our main duty is we need to identify the data driven. Why? Because already information is available. By taking the help of that information, we need to prove something. So we can say that it is a data driven. But here this one is a goal driven. Okay, only the thing is you need to identify which process is suitable to your specific problem. So based upon the form of the rules, one can decide whether the same rules can be applied to both forward reasoning and backward reasoning. Okay, means the topic is telling that, can I use the same rules to perform forward reasoning and backward reasoning? So it depends upon you. If you feel that the same rules are applicable to move from initial state to goal state and coming from goal state to move state, then it's okay to use the same kind of rules. If it is not the case, then you have to search for the new rules. Okay, so this is all about the inference engine, forward reasoning and backward reasoning, and these are the references I have used to produce the content shown in the slides. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.